This is Lauren, Physics 350, Homework 5. I'm doing question number 4 from Homework 5 because I got question 3 back and I did it completely wrong. I don't understand why. So I'm not going to explain a problem incorrectly on here. And I'm also not doing the problem that we turned in on Thursday because I can in no way explain it in less than 3 minutes. So I'm going to do this one instead. So, number 4, in class we did an example where we used the method of images to solve for the potential for a system consisting of a grounded sphere and a point charge of distance d from its center and outside its surface. So we're going to use the same technique to find the potential if the grounded sphere is replaced by an insulated conducting sphere. So we basically had a sphere that was grounded and then we removed it from ground so it has a net charge of 0. But that doesn't mean it has a definite potential. But it still must be equipotential. So we're going to figure out the charge of the image charges and their locations, and we can use previous results here, but we're going to explain ourselves. So here we go. So here's our picture. This is the charge that we found in class because we did a grounded sphere. So we know from class that V at the boundary is 0 for a grounded sphere. So we placed a charge of this value at a location of this, and that's something that we did in class, and that's this charge right here. It's not in the center. So then what we can do is, now that V is 0 on the boundary, we can put a charge Q double prime at the center of the sphere, and that'll give us a constant potential along the boundary. And we know that the potential due to a point charge at the surface is going to be this right here, V1 over 4 pi epsilon naught, and then Q double prime is what we're going to call the charge that we put at the center, over r, which is the radius of our sphere. So then if we solve for Q prime, we get that Q double prime is 4 pi epsilon naught times the radius times V double prime. So that gives us a constant V on the boundary.